Hello, sorry, last video was cut in the middle unknowingly. So we'll continue the same topic and then go with the conversion of Greek code to binary and vice versa. So shaft position encoders ಅಂತ ಹೇಳಿದ್ನಲ್ಲ, I was explaining this. Like if I consider this as a rotating disk as well as this as a filler, ಯಾವಾಗ ಗ್ಲಾಸ್ ಅಥವಾ ಯಾವಾಗ ಬಾಟಲ್ ಅಲ್ಲಿ ಜ್ಯೂಸ್ ಫಿಲ್ ಆಗುತ್ತೋ then the sensor will sense the level of the juice and sends the signal to the filler with the help of a transducer, and the filler will be turned off automatically. Once the bottle is filled, the rotating disc will rotate at some angle, like making sure that an empty bottle comes exactly below this filler once again. So ಈ ತರ ಒಂದಾದ್ಮೇಲೆ bottles fill ಆಗಿ each and every bottles placed on the position of the rotating disc will be filled and then it will be packed. ಬರೀ ಜ್ಯೂಸ್ ಇಂಡಸ್ಟ್ರೀಸ್ ಅಂತ ಅಲ್ಲ, ಎಲ್ಲೆಲ್ಲಿ ನಾವು ಪ್ಯಾಕಿಂಗ್ ಫಿಲ್ಲಿಂಗ್ ಆಸ್ ವೆಲ್ ಆಸ್ ಪ್ಯಾಕಿಂಗ್ ಇರುತ್ತೋ ಅಂತ ಕಡೆ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಯೂಸ್ ದಿಸ್ ಶಾಫ್ಟ್ ಪೊಸಿಷನ್ ಎನ್ಕೋಡರ್ಸ್. And the second type of application is this analog to digital conversion. In this analog to digital conversions, we are using in a vast manner this one, analog to digital conversion. ಇಷ್ಟೊಂದು ಅಪ್ಲಿಕೇಶನ್ಸ್ ನಲ್ಲಿ we are using, and we are going to study about this topic in detail in one of the next topics. ಈ ಟಾಪಿಕ್ ನಿಮ್ಮ ಸಿಲೆಬಸ್ ನಲ್ಲಿ ಇನ್ಕ್ಲೂಡ್ ಆಗಿರೋದ್ರಿಂದ ಯಾವ ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ಅನಲಾಗ್ ಟು ಡಿಜಿಟಲ್ ಕನ್ವರ್ಷನ್ಸ್ ಇದೆ ಅಂಡ್ ನಾವು ವಾಟ್ ಆರ್ ದ ಡಿಫ್ರೆಂಟ್ ಅಪ್ಲಿಕೇಶನ್ ಲೆವೆಲ್ ಆಫ್ ದಿಸ್ ಅನ್ನೋದನ್ನ we are going to study in detail in the further topics. And the last one is reduce errors that occur in data transmission. We know that whatever the data you're going to feed into the computer with the help of keyboard, that will be converted into a binary language or a digital language, and that binary language will be transmitted to a large distance or a shorter distance to the receiver, and at the receiver end again that data will be converted back into analog language and that will be displayed, or to the language what we can understand. So if there is any kind of errors in between while transmitting the medium, then the data will be completely changed. So that types of errors can be reduced with the help of this Greek code. Say for example, a hexadecimal ನಲ್ಲಿ a ನ ನಾವು ಬೈನರಿ ನಲ್ಲಿ ಹೇಗಂತ ಬರ್ತೀವಿ 1010 ಅಂತ ಹೇಳ್ತೇವೆ. So while transmitting 1010, because of some errors, if it goes like this 1011 ಅಂತ ಏನಾದ್ರು ಹೋಯ್ತು ಅಂತಂದ್ರೆ it will be read as 11 which will be equal to b. So complete ಆಗಿ ಡೇಟಾ ಏನಾಗುತ್ತೆ, a ಬದಲು b ಅನ್ನೋದು ಹೋಗುತ್ತೆ. So the data will be completely changed. Such types of errors can be eliminated with the help of this Greek code. So these are some of the applications of the Greek code. And next, we are going to see how to convert a given binary number into Greek code or vice versa. First, let us see how to convert a given binary number into Greek code. After the explanation of this conversion, I am going to give you some homework problems, and I want you to solve those problems and send me the picture of those separate. Okay. First, binary to Greek code ಅಥವಾ ಸೈಡಲ್ಲಿ ಒಂದು ಕಡೆ ಬರ್ತಿರ್ತೀನಿ b to g. So the very first problem is 1001 ಅನ್ನೇ ತಗೊಂಡು 1001 to the base 2, you have to convert this into Greek code. To the base g ಅಂತ ಬರೆದ್ರೆ it's nothing but Greek code ಗೆ convert ಮಾಡಬೇಕು ಅಂತ. So what you have to do is ಯಾವ ನಂಬರನ್ನ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು that you are going to write on the top, and you have to write that number horizontally with some distance like this. This is our MSB. MSB ಅಂದ್ರೇನು most significant bit, and this is our LSB. That is the bit which is to the rightmost corner. This is LSB, and the bit which is to the leftmost corner, that is MSB. That is the most significant bit. And I need to convert that into Greek code that I am going to write below the binary number. Now listen to me very carefully. The MSB of the Greek code is same as the MSB of the binary. MSB of the Greek code ಏನಿರುತ್ತೆ ಅಂದ್ರೆ that will be same as the MSB of the binary. Binary value ಇಂದು MSB 1 ಇದ್ರೆ it will be equal to 1. Binary value ಇಂದು MSB 0 ಇದ್ರೆ even this will be equal to 0. So I'm just going to write an arrow mark over here, so telling that the MSB of Greek code will be same as the MSB of the binary. Next, how to convert ಅಂತ ಹೇಳಿದ್ರೆ we are going to check this with the help of an XOR table. Sorry, I just forgot to write that XOR table, XOR truth table. XOR the truth table anta bandaga, if A and X are the, if A and B are the two inputs and Y is the output, I'm going to get four different combinations: 0 0 0 1 1 0 1 1, and the output of this XOR truth table will be equal to 1 when odd number of inputs value is equal to 1. ಆಡ್ ನಂಬರ್ ಆಫ್ ಇನ್ಪುಟ್ ವ್ಯಾಲ್ಯೂ ಯಾವಾಗ 1 ಇರುತ್ತೋ ಅವಾಗ ಮಾತ್ರ ಔಟ್ಪುಟ್ ನನಗೆ 1 ಇರುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಎರಡು ಕೇಸ್ನಲ್ಲಿ, ಫಸ್ಟ್ ಕೇಸ್ನಲ್ಲಿ ಬೋತ್ ದ ವ್ಯಾಲ್ಯೂಸ್ ಆರ್ ಈಕ್ವಲ್ ಟು 0, ಸೊ ದ ಔಟ್ಪುಟ್ ವಿಲ್ ಬಿ ಈಕ್ವಲ್ ಟು 0. ಅಂಡ್ ಇನ್ ದ ಲಾಸ್ಟ್ ಕೇಸ್ ಬೋತ್ ದ ವ್ಯಾಲ್ಯೂಸ್ ಆರ್ ಈಕ್ವಲ್ ಟು 1, ಅಂದರೆ 2 ನಂಬರ್ ಆಫ್ ಇನ್ಪುಟ್ಸ್ ವ್ಯಾಲ್ಯೂ ಇಸ್ ಈಕ್ವಲ್ ಟು 1, ಅಂದರೆ ಈವನ್ ನಂಬರ್ ಆಫ್ ಇನ್ಪುಟ್ ವ್ಯಾಲ್ಯೂಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 1. So the output will be equal to 0. But here in these two cases, odd number of inputs value, ಇಲ್ಲಿ ಈ ಕೇಸ್ನಲ್ಲಿ ಬರೀ ಬಿ ಮಾತ್ರ 1 ಇದೆ, and in this case only a value is equal to 1. Odd number of input value is equal to 1. So the output of these two cases will be equal to 1. This is the truth table of XOR gate, and this is the symbol of XOR gate. You have to remember this very, very carefully. If a and b is the input, y is the output, a x or b ಈ ತರ ಬರುತ್ತೆ. Okay, now so let's come back to the conversion part. The MSB of the gray code is same as the MSB of the binary. Now I want to get the second MSB. For that, what you're going to do, the first MSB of the binary must be XORed with the second MSB of the binary. ಈ ಎರಡು bits ಮಧ್ಯ we have to do XOR. This and this must be XORed and the output must be written here. 1 and 0. If I consider this as A and this as B, A value is equal to 1, B value is equal to 0, A is 1, B is equal to 0, then the output will be equal to 1. Clear? Then we'll move on to next. This and this must be XORed, 0 and 0. ಎರಡು value 0 0 ಇದ್ದಾಗ output is equal to 0. Clear? Then ಸ್ವಲ್ಪ ಈ ಕಡೆ ಬರೀತೀನಿ. This and this has to be XORed. A value is equal to 1, sorry, A value is equal to 0 and B value is equal to 1. A is 0, B is 1 andaga output is equal to 1. So 1001 to the base 2 anta ಹೇಳಿದಾಗ, when I'm going to convert, its value will be equal to like this. 1001 to the base 2 is equal to 1101 to the base G. To the base G and it is a gray code. So let me brief it once again. The MSB of the gray code is same as the MSB of the binary. And the second MSB of the gray code will be got by XORing the MSB of the binary with the second MSB of the binary. ಈ ಎರಡನ್ನು XOR ಮಾಡಿದಾಗ you are going to get the second MSB. The third MSB of the gray code will be got by XORing the second MSB and the third MSB of the binary code. Like this, ಈ ತರ XOR ಮಾಡ್ತಾ ಹೋದ್ರೆ you are going to get the answer. So the answer is 1101 to the base G. This is the simplest method of converting. There is another method to convert this binary code into a gray code using XOR gates. XOR gates ಅನ್ನ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಸಾಲ್ವ್ ಮಾಡಿ ಅಂತ ಕೇಳ್ತಾರೆ. ಆವಾಗ ಹೇಗೆ ಸಾಲ್ವ್ ಮಾಡೋದು ಅಂತ ಇವಾಗ ತೋರಿಸ್ತೀನಿ. They are going to specify you convert the given binary number into gray code using XOR ಅಂತ. ಆವಾಗ ನೀವು ಈ ಮೆಥಡ್ನ ಫಾಲೋ ಮಾಡಬೇಕಾಗುತ್ತೆ. Here in the earlier case we had written the binary number in the like in horizontal manner. Here I am going to write the binary number in the vertical manner. This is a binary number and this is the MSB, this is the LSB. I need to convert these numbers. As I told you, this is a gray code. The MSB of the gray code is same as the MSB of the binary. E number same. Here, if it's 0 over here, even this will be equal to 0. Now, ಆಮೇಲೆ ಮಾಡಿದ್ವಲ್ಲ 1001 ಈ ಎರಡರ ಮಧ್ಯೆ XOR ಮಾಡಿದ್ವಿ, ಅವಾಗ ಆನ್ಸರ್ ಬರುದ್ವಿ ಗೊತ್ತಾನೆ. ಆಮೇಲೆ ಇವೆರಡರ ಮಧ್ಯೆ ಮಾಡಿದ್ವಿ, ಇಲ್ಲಿ ಬಂದ್ವಿ. ಸೊ ದೀಸ್ ಆರ್ ದ ಇನ್ಪುಟ್ಸ್. ಈ ಫಸ್ಟ್ ಇನ್ಪುಟ್ ಅನ್ನ ಹೀಗೆ ಬರ್ದಾಯ್ತು. MSB of this gray code is same as MSB of binary. ಹಾಗೆ ಬರ್ದಾಯ್ತು. Now this MSB and the second MSB must be XORed. This MSB and second MSB must be XORed in order to get an output. So this value is equal to 1. ಇಲ್ಲಿ ಶಾರ್ಟ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಷ್ಟೇ. This is equal to 0. 1 0 ಇರುವಾಗ ಔಟ್ಪುಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 1. Similarly, second MSB, third MSB must be XORed. This value is equal to 0, this value is equal to 0. ಎರಡು 0 0 ಇತ್ತು ಅಂದರೆ ಔಟ್ಪುಟ್ ವ್ಯಾಲ್ಯೂ ಇಸ್ 0. Clear? And this third MSB and the LSB must be XORed to get this is 0, this is equal to 1, 0 1 ittu anta ಹೇಳಿದ್ರೆ output is equal to 1. So you got the same answer, 1101 to the base G. So this is how you are going to convert a given binary number into a gray code using XOR gate. This is how you have to follow. But one thing what you have to remember is the truth table of an XOR gate, where A and B are the two inputs and B is the output. Clear? And the next topic is conversion of a given gray code to binary. ಈಗ binary to gray code ಹೇಗೆ ಮಾಡೋದು ಅಂತ ನೋಡಿ. Now let us try to understand how to convert a given gray code to binary. Let us retain this XOR truth table as it is. Now gray code to binary. Let me write here as G to B. ಈಗ ಪ್ರೀವಿಯಸ್ಲಿ ಬರೆದಾಗ ಬಿ ಟು ಜಿ ಬರೆದಾಗ ಬೈನರಿ ಟು ಗ್ರೇ ಮಾಡಿದಾಗ ಇನ್ ದ ಆಲ್ಫಾಬೆಟಿಕಲ್ ಆರ್ಡರ್ ಬಿ ಕಮ್ಸ್ ಫಸ್ಟ್ ದೆನ್ ಜಿ. ಸೊ ಐ ಹ್ಯಾವ್ ಟು ಗೋ ಇನ್ ದ ಫಾರ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಇನ್ ಆರ್ಡರ್ ಟು ಗೆಟ್ ಜಿ ಫ್ರಮ್ ಬಿ. ಅಂದರೆ ಇನ್ಪುಟ್ ನಂಬರ್ಸ್ ಏನಿತ್ತು ಅದೇ ಥರ ಹೀಗೆ ಹೋಗಬೇಕಾಗಿದೆ. ನಾವು ಸ್ವಲ್ಪ ಸ್ಲೈಟ್ ವೇರಿಯೇಷನ್ ಇದೆ, ಏನು ಅಂತ ನೋಡೋಣ. ಇದಕ್ಕೆ ಕನ್ವರ್ಷನ್ಗೆ ಲೆಟ್ ಅಸ್ ಟೇಕ್ ಅನದರ್ ಎಕ್ಸಾಂಪಲ್, ದಟ್ ಈಸ್ the given 1101 to the base G. You have to convert this into binary ಅಂತ ಕೇಳ್ತಾರೆ. ಬಿ ಅಂತನಾರು ಬರಿಬೋದು ಅಥವಾ ಜಿ ಅಂತನಾರು ಬರಿಬೋದು. Sorry, B ಅಂತನಾರು ಬರಿಬೋದು ಅಥವಾ 2 ಅಂತನಾರು ಬರಿಬೋದು. Usually we are going to write it as 2. So this is the gray code 1101. This is the MSB and this is the LSB. Most significant bit and least significant bit. Now I want to convert this into binary. The MSB of the binary is same as the MSB of the gray code 1. ಮುಂಚೆ ಏನು ಮಾಡಿದ್ವಿ, ಈ ಎರಡನ್ನ XOR ಮಾಡಿ ಬಂದಿದ್ದ ಆನ್ಸರ್ನ ಹೀಗೆ ಬರ. Now we are going to go in a zigzag manner. The MSB of the binary will be XORed with the second MSB of the gray code and you are going to get the second MSB of the binary. ಈ ನಂಬರ್ ಮತ್ತು ಈ ನಂಬರನ್ನು XOR ಮಾಡಿ ಬಂದಿರುವಂಥ ಆನ್ಸರ್ನ ಇದು ಮಾಡಿ 1 and 1. 1 1 ಅಂತ ಹೇಳಿದ್ರೆ output will be equal to 0. Now this must be XORed with this 0 0 ಅಂತ ಹೇಳಿದ್ರೆ its value is equal to 0. Now this must be XORed with this 0 and 1. The value is equal to 1. So 1101 is the answer. So 1101 to the base G, the answer 1001 to the base 2. This is the answer what we are going to get. This is the MSB and this is the LSB. The same question or the same type gray to binary conversion using XOR gates ಅಂತ ಕೇಳಿದ್ರೆ you have to do it in the same manner. ಅದನ್ನೊಂದು ತೋರಿಸ್ತೀವಿ. ಸೊ ಯಾವುದು ಇನ್ಪುಟ್ ಇದೆಯೋ ಅದನ್ನು ವರ್ಟಿಕಲಿ ಬರ್ಕೊಳ್ಳಿ. 1101, ದಿಸ್ ಇಸ್ ಅ ಗ್ರೇ ಕೋಡ್ and this is the MSB of a gray code, this is the LSB of the gray code. I have to convert that into binary. I already told you the MSB of the binary is same as the MSB of the gray code. So I'm just going to write a direct arrow mark and leave it. Now ಇಲ್ಲಿ ಏನು ಮಾಡಿದ್ವಿ, 1101 ಬರೆದ್ರೆ ದಿಸ್ ವಾಸ್ MSB and this was LSB. ಇದನ್ನು ಹಾಗೆ ತಗೊಂಡಿದ್ವಿ. ಇದು ಮತ್ತೆ ಇದು, the first MSB of the binary and the second MSB of the gray code must be XORed. first MSB and the second MSB of the gray code must be X or in order to get an output. This value is equal to 1, this value is equal to 1, 1, 1, its value is equal to 1, 1, its value is equal to 0. ಸೊ ಇದು ಬಂತು 0 ಅಂತ ಬರುತ್ತೆ. ಆಮೇಲೆ ಏನು ಮಾಡಿದ್ವಿ, ಈ ಆನ್ಸರ್ನ ಇದ್ರ ಜೊತೆ ಎಕ್ಸ್ ಮಾಡಿ, ಈ ಆನ್ಸರನ್ನ ಒಂದು ಇನ್ಪುಟ್ ಥರ ತಗೊಳ್ಳಿ, ಇದನ್ನ ಇನ್ನೊಂದು ಇನ್ಪುಟ್ ಥರ ತಗೊಂಡು ಎರಡನ್ನೂ ಎಕ್ಸ್ ಮಾಡಿ, ದಿಸ್ ವ್ಯಾಲ್ಯೂ ಇಸ್ ಈಕ್ವಲ್ ಟು 0, ದಿಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 0, ಎರಡು 0 0 ಇರುವಾಗ ದ ಔಟ್ಪುಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 0. Clear? And the last, this as one input, this as another input, and this is equal to 0, this is equal to 1, 0 1 ittu andre its value is equal to 1. Again I got the same answer, 1001 to the base 2. This is MSB of the binary and this is LSB of the binary. Hope you are clear with this method also. Yes, we are having two different methods. One is direct conversion, the other one is using XOR gates. Both you have to practice, and exam ಅಲ್ಲಿ ಯಾವ particular method ಕೇಳ್ತಾರೆ, if they are going to specify that you have to solve using XOR gate, only then you have to follow this method. Otherwise you can directly write that answer. Okay, after this video I am just going to give you the some of the problems as homework. You have to solve those problems using both the methods. ಆಯ್ತಾ, ಎರಡು ಮೆಥಡ್ಸ್ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಸಾಲ್ವ್ ಮಾಡಿ ನನಗೆ ಆನ್ಸರ್ನ ಇಂಡಿವಿಜುವಲ್ ಆಗಿ ಪಿಕ್ ಕಳಿಸ್ಬೇಕು. ಸೊ ದಿಸ್ ಟೈಮ್ ಐ ಯೂಸ್ಡ್ ವೈಟ್ ಬೋರ್ಡ್ ಟು do this class. I hope you like it, and I want you to send me your feedback, like this is better or the exam pad nal bariyod better, whichever you feel comfortable. You please do tell me your opinion after seeing this class. Okay, see you in the next topic. Bye bye.